Just 59 minutes past noon on March 1st, 2026, a quiet day in Nebraska was interrupted by something unexpected, an earthquake. Registering in as a magnitude 4.1 and centered 28 miles south of the city of Hastings, it caused the ground to shake back and forth for several seconds. While not causing any notable damage due to its small magnitude, there were reports of items falling off of shelves along with paintings loosely hung on some walls falling off. Regardless, this earthquake was scientifically interesting for a number of reasons, the least of which was the fact it represented Nebraska's 9th largest recorded earthquake, or that it struck in an area of the state assigned the second lowest of seismic hazard colors. In total, around 9 million people across at least portions of 5 states felt this earthquake, which occurred due to the motion of a buried oblique fault line with an epicenter about 9,800 feet below ground. The fault line in question moved with elements of both horizontal and vertical motion, specifically a left lateral strike slip fault combined with a normal fault. Now, I want to note something interesting in regards to my interpretation on how the March 1st earthquake occurred in the first place. To me, it seems like a deep and buried 1.7 billion-year-old weak point in the crust slip due to broad regional stresses simply forcing such a spot to slip ever so slightly. More specifically, I believe that this earthquake might have occurred on a fault line related to the Central Plains orogeny 1.7 billion years ago. As, buried more than 3,000 feet beneath far younger rock units, across much of Nebraska there is a widespread and thick Precambrian age rock unit from that period. This buried mass once represented a towering mountain range, largely tilted and composed of high-grade metamorphic rocks along with granite. The aforementioned tilting and compression this ancient orogeny caused resulted in many faults forming in the ancient crust, some of which remain today. Thus, when regional strain is applied to a section of Nebraska, causing slightly uneven stresses on a particular area, such buried faults from the Central Plains orogeny are often the most likely modern spots in the crust to accommodate the strain and slip if there are no surface faults present nearby. I want to also note that the vicinity surrounding this week's earthquakes had no record of seismic activity until 2022, and since then, 17 earthquakes have occurred there. All of these earthquakes involved oblique, normal, or strike slip faults, and all seemingly involved faults striking to the northwest. While it might seem like there could be a lineament visible in the nearby landscape of the 4.1 earthquake, especially because several regional drainage channels also trend in that direction, I don't think the fault lines in question are exposed anywhere on the surface. Well, one Nebraska geologist I contacted suggested that seismicity could be related to dramatic groundwater level changes since the early 1900s that have occurred across portions of the state. Detailed maps did not seem to show any major changes during that time span where the earthquakes happened. In my opinion, I instead think that all 17 of these earthquakes that have struck since 2022 merely represent a foreshock, main shock, and then aftershock sequence related to a magnitude 3.4 main shock quake that struck on September 18, 2023. While that aftershock sequence did seemingly end, it may have directly triggered the most recent earthquake sequence that involved a magnitude 4.1 main shock and 2 magnitude 2.6 aftershocks. Speaking of aftershocks, these are the U.S. Geological Survey statistical estimates for the odds of various magnitude aftershocks occurring in a following set period of time. However, in my opinion, this model didn't take into account the lack of large fault lines in the region, so in reality the odds probably look more like this: absolutely zero chance of a magnitude 6 or larger earthquake striking. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube for supporting my work.